Hi guys, it's Jason here, and I'm presenting another installment, edition 3 of my linked list series. Now, in the previous edition, what I did was I implemented the type of a linked list, and then I implemented the basic getter functions, which is num items, which returns how many items are in the list, get nth item, which tells you which item is in which particular position, and show list, which prints out the entire list. And in this video, I'll be focusing on the insert functions, and these are the three functions here. Insert head is going to be a function that inserts a node at the start of the list. Insert end is going to be a function that inserts a node at the end of a list. And insert node is going to be a general insert which can insert at any position in the list. So I've written some tests for all these functions in test list here. And the purpose of writing these inserts is so that we can also test our num items function in our get nth item function as well. So the first thing I'm going to do is I'm going to insert a 1 at the start of the list. So our list will just contain one item, which is 1. And the number of items in the list should be 1. And the 0th item, if you count using computing terms, which starts at 0, you'll get a 1. Secondly, I use insert head again, but this time I'm going to insert a 2 at the start. So once again, the number of items should increase by 1, so now it's 2. And the first item should be, well, the 0th item I should say, would be a 2, and the 1th item will be a 1. And then after this, I'm going to insert the number 3 at the end of the list. So this time there will be 3 items in the list. The first item will be a 2, or the 0th item will be a 2, the 1th item will be a 1, and the second item will be a 3. And then after that, we'll do 3 cases of insert node. One where we insert it in the middle, one where we insert it at the end, and one where we insert it at the start. Here we're inserting the number 100 into position 2. So after we do that, we should have 4 items in the list, and our list should go 2, 1, 103. Now we're going to insert an 1000 at position 4, which is at the end of the list. So after we do that, there should be 5 items in the list, and our list should read 2, 1, 103, 1000. And the last thing we're going to do is insert 1337 at position 0. So after we do that, we should have 6 items in the list, and our list should read 1337, 2, 1, 103, and 1000. And if our 3 functions are written correctly, we should see the message insert function test passed. Well, hopefully. So our next job is to write these functions. And we'll start with insert head. So how do you insert head? Alright, so here is our list, and we want to insert something to the start of a list. So say we have this magical purple node. The first thing we have to do is create a new node. So we have to create, we have to create a new node. And of course we need to store a pointer to the new node as well, so we know where it is. Okay. The second thing we're going to do is, given this new node, we're going to set it to the original start of the list. So we're going to create this arrow here. And finally, what we need to do is change the head of the list. It needs to now point to the new node. So instead of making it point to the original first head, we have to make it point to the new node instead. So those are going to be our 3 basic steps. Okay. So let's just write that in pseudocode. So the first step is create new node. The second step is going to be new node points to old head. And the third one is going to be change head to new node. Alright, so let's actually do that. To create a new node is fairly simple. So we have, we'll call it new node, just for lack of originality, and of course because we are dealing with a pointer here, we have to malloc it. So it's of type node pointer, new node, and we have to malloc it, so we go malloc, and the size of a new node, well, we don't know that yet, but we can use this trick, struct node. Alright, so we've created our new node. Now we have to make new node point to the old head. So if we remember, the second arrow we drew was this one. So new node points to this purple circle, and we want to alter the value. We want to make it point to the old head. So we better store that somewhere. So we have a node pointer old head, and the old head is simply the list's head, L arrow head. And then we want to make new node its next field equal to old head. So now what we've effectively done is we have populated this second arrow here, but we're still missing the arrow that connects it to the original new node. So what we have to do at the end is change the head. So of course, we go L arrow head. This is a reference to the head, and we assigned it the value of, we want to make this arrow change it to that arrow. So since this arrow and this arrow are pointing to the same thing, we just make it new node, because new node is a pointer to the new node. And are we done? Well, actually no, I just forgot something. Of course we have to populate the values. So new node value. So the value field, we're going to assign it data. Alright, so let's see if that compiles. GCC minus wall minus square o minus big O minus little o, and we call it list tester, and we have list.c and test list.c. Does it compile? And it does. Oh, that's a bit scary. Alright, let's run it. So insertion failed, and of course, because so what we were able to do is we insert a 1 at the start and insert a 2 at the start. You can see that here, but we couldn't insert a 3 at the end, of course, because we haven't written the insert end function yet. So that makes sense. However, we should just double check that everything else works fine, so we'll probably just comment that out. So everything from here, we can't test to here, we can't test yet. So we'll probably just make sure that everything else works before progressing. And we can see at the bottom here, yes. So at first we inserted a 1, yep, that worked. We inserted a 2 at the start, so now it becomes 2 and 1. And at the end we say, all tests passed, you are awesome. Okay, that's good. So our insert head function works. The next function we should write is insert end. Okay, and we should probably change our tests to reflect that we now have an insert end, but we don't have an insert node yet. So we'll comment this stuff out, and let's write insert end. Alright. So inserting at the end is actually a little bit simpler than inserting at the head. Like always, whenever we're inserting something, we have to make the new node first. So we'll make it in purple because purple's a nice color. So we have to create a new node. We'll give it the value, I don't know, 8. And then we have to create a new node, and we have to also create the pointer to the new node. And this pointer, we'll just call it new node. Alright, so that's the first step. The second step we have to do is we have to find the last node of the list. And we can easily do that. We sorted out how to do that before in our second video. And if we do that, we have something called, well, technically we should call it old last. Old end, if you want to make it more clearer. So we have a pointer to the old end. Now, the third thing we want to do is we want to cancel this arrow here, make it point to this. And then the fourth thing we want to do is make that point to the end. So that's what we want to do in 4 steps. First step, create a new node. Second step, find the end of the list, or the old end of the list. Third step, make the old end point to the new node. And fourth step, make the new node point to null. So we'll write that in pseudocode. So the first step was to create a new node. Second step was to find the end of the list. The third step was to set old end to point to new node, and the fourth step, set new node to point to null. Well, actually, it turns out we could probably do that when we create a new node anyway. So, yeah. So let's do the first step. So once again, to make a new node, we just malloc it. So we can use the exact same code as this. So we just copy it here. And of course, we also want to make sure that at the end it points to null. So we do this. New node arrow next equals null. So now what we've done is we've done these 2 steps. We've created the purple node, and we've also set it to null. The second step we have to do is we have to find the old end. And this is a pretty simple while loop. So we'll create a node pointer old end. We will initialize it to the first element of the list, which is a pointer to the first node of the list, which is L arrowhead. And then we have to find the end. So we do this little while loop. While old end arrow next is not equal null. Basically just advance it. So old end, go assign it the value of the next one. And this is a very common technique for looping through linked lists, this kind of trick here. Alright, so what that's going to do is, firstly, old end is going to be pointing to the first node. Does that point to null? No, so it's going to shift over. Does that point to null? No, so it's going to shift over. Does that point to null? Yes, so it's going to stay there. And then finally, the third step is we want to create this red arrow here. So old end arrow next will point, I should put this comment above this because it makes more sense. So the last thing we need to do is old end arrow next equals new node. So basically what that's doing is it's setting this red arrow here to point to the same thing as new node, which is this purple arrow here. And after doing those 3 steps, we should have our insert at end function. Alright, so let's see if that compiles. Just drag this down a bit. Alright, let's go. And it compiles. Now for the moment of truth. Let's see. So we're testing our insert functions. We inserted 1 at the start. That's good. Inserted 2 at the start. That's good. And inserted 3 at the end. So our thing becomes 2, 1, 3. And all tests passed. You are awesome. Alright. And then we go to the final part of our video, which is the general insert. In other words, insert in any position. This is going to be a lot trickier. But first, we should uncomment these. Okay. Now, to insert at any position is a lot trickier than just inserting at the start or inserting at the end. And there are several cases that you have to consider. The first case, which is the most basic case, surprisingly, is where we're inserting in the middle. So, like always, when we insert a node, we actually have to create the new node first. So we create a new node like this. And of course, we also have to create the pointer to the new node. And we'll call that new node. The next thing we want to do is we want to create pointers which point to the node that comes before the inserted node, so here, and the node that comes after the inserted node, so this one. In other words, we want to create two pointers before and after, so kind of like this. And we'll call them before and after, because that makes sense to me. Before and after. And that isn't too hard to do. We can do that for a while loop. So, this initial black arrow here, it's pointing between before and after. We want to make this, we're going to get rid of this black arrow and replace it with two arrows, like so. So we want to kill this, black arrow, and make it do this, basically. So that's our basic strategy for inserting a node. Alright. So let's do it. Okay. So in pseudocode, our first step is to create a new node, as always. The second step is to find node before and after the insert. And our third one is to we'll just call it adjust the arrows. Alright, so to create a new node, it's the same as we've been doing the last two times. We simply malloc a new node and then put the data inside it. Note that we can't fill in the next field yet because we haven't found where this before and after is. So that's our next step, to find that before and after. And this is going to be quite tricky. So let's just say you wanted to insert a new node at position 2. So which is what we've drawn here. Before is going to point to position 1 of the old list, and after is going to point to position 2 of the old list. Okay, so keeping that in mind, we need a while loop that in our case we want to find the before and after at positions 1 and 2. Okay, so let's do that. Int count equals 0 while, and we don't know what our condition is exactly yet, but we'll fill it in later. The other thing we need, the other two things we need are node pointers. So node pointer before and a node pointer after. Alright, so let's look at this logic more carefully. Initially, we'll just make the before one point to the same one as this red arrow. Sorry, wrong picture. This red arrow, and we'll make after point to the one after it. All right. L arrow head, and after will point to before arrow next, which is the next point to the next node, basically. All right. So what we had before is, no pun intended, at the initial state they're going to point to these two nodes. And so if we're inserting at position 2, we want to shift them both over once. That means in our while loop we want to loop it n-1 times. So normally we would do count is less than position, but because we want to repeat n-1 times, we would do count is less than position minus 1. Alright, and then of course we need to advance the pointers, so before equals before arrow next, and then same with after. After equals after arrow next. Alright, so that's finding the arrows before and after it. And the final thing we need to do is adjust those arrows. So, we've created this purple part. We've created the 2 pointers before and after, the orange parts. Now we need to do the red stuff. So, the original black arrow, which we're trying to kill, is before arrow next. We want to assign that to point to the same thing as new node. So in other words, what we're saying is before arrow next equals new node, and that will create this red arrow here. Before arrow next equals new node, and the other thing we want to do is create the second red arrow here. So new node arrow next, we want it to point to after. Okay, so new node arrow next equals after. Alright, and if our code is correct, hopefully this will pass our unit tests. Let's compile. GCC, and so it compiled. Let's see if the tests passed. Whoops, I named it wrong, this tester. Alright, so it looks like we have reached an infinite loop of sorts. And why is that? Let's have a look. Oh, silly, we didn't go count plus plus. Always progress your loop. Alright, let's do that again. So GCC, see if it compiles, let's tester. Alright, so it didn't quite work. Let's see what happened. The new list was created. Yes, we know that insert head works, we know that insert end works. Inserting 100 at position 2, that worked. Inserting 1000 at position 4, that worked. Inserting 1337 at position 0, and notice that it didn't insert it at position 0, it inserted it at position 1. That didn't work. So this was the exception that I was referring to before. There is a separate case for when we insert at a random position and when we insert at the end. Because if we're inserting at the start, remember what we had to do was we actually had to change the head itself. So, okay, this is going to become a little bit more difficult, but we have to have an if statement. So, if position, I'll put the brackets around of course, equals 0, else do that stuff. So if position equals 0, which means inserting at start, otherwise inserting elsewhere. So when we're inserting at start, something special happens. If we want to insert at position 0, so we want to do this, notice how now we have to change the list to point to the new node. Our after becomes this, and our before node, well, we don't need it, so we'll just turn it into a null. So we'll set before to null, and our after is going to be our arrowhead. Alright, that's cool. And of course, when we adjust the arrows, we have two cases. We have it if it's at the start, and if it's somewhere else. Else, well, if I could type, that'd be nice. Okay, if position equals 0, we have to do something special. So instead of adjusting before, we have to adjust the head. So L arrow head, we want to make it point to the new node, so we want to create this red arrow here. Alright, and new node arrow next still is after, so we still want to keep that. Alright. And hopefully after that it should compile, so let's have a test. That's good, and let's go list tester. And the last one finished, 1337 at position 0, and we're passed. We are awesome. Okay, so that's how you implement the insert functions for a linked list. In the next video I'll be doing the delete functions. Until then, see you later.